Hello, and thank you for joining us for today's webinar. We're continuing our webinar series focused on mainframe security compliance. Today's topic is STIGs. We'll look into how to think about them, how they can benefit your organization, and a way to automate your mainframe STIGs. First, here's a brief introduction to Software Diversified Services. Our headquarters are located in Minneapolis, Minnesota. We have been around since 1982 and maintain over 25 mainframe products. Our focus is on helping organizations fill their cybersecurity and compliance needs for the mainframe. We have several security solutions that will help you secure your mainframe while assisting you with even the most cumbersome compliance regulations. Please see our mainframe security handout for additional information. We have a webinar coming up on May 16th that will offer a practical approach to transforming your business's technology using the Virtel Web Suite. The suite centers around a thin client 3270 terminal emulator that offers the highest level of security. Plus, we'll be at Share Pittsburgh in early August for the Tech Expo. We hope to see you all there. We are happy to have Stu Henderson, the founder of Henderson Group, noted mainframe security expert and auditor, presenting How to Think About STIGs. His presentation will be followed by Gary Bortner, Quality Assurance and Support Technician at SDS. He will demonstrate how IronSphere for ZOS can automate the STIG monitoring process. We will wrap things up with a short Q&A at the end, so be sure to type in your questions throughout the webinar. If we don't have time for all your questions, we'll be sure to provide you a response shortly after the webinar. Now, let me introduce Stu Henderson. Stu, it's all yours.
Thanks, Lisa. Today we're going to talk a little bit further about how to use the STIGs for compliance. If you're going to talk about compliance, you have to have a standard, and a very good way of developing a standard or a starting point for mainframe security is the government-provided STIGs, the Security Technical Information Guides. So what we're going to do is use three examples to show you how you can take advantage of the STIGs in developing your own standards to set you up for your own compliance evaluation. Our agenda is simple. We'll do a little introduction. We'll give three examples that will give you some ideas of how to deal with the STIG. We'll wrap it up with a summary and a call to action. We often start with the STIGs to develop our standards because they're as comprehensive as anything else we have to go with. They give us a good starting point. You can download the STIGs for free from the government websites, and the last slide of this presentation will have several links for additional information. I want to point out, though, that the G in STIG stands for guide, and this will be our clue throughout this presentation. It doesn't stand for law or regulation or even standard. The suggestions in the STIG are guidelines for things for you to think about. If you're the military, you may need to use them. If you're a commercial site or a non-military government site, you'll take everything with a grain of salt, and you'll see that as we go through this. A little understanding here for the STIGs. They were developed by the US government for different levels of criticality, but they were also designed as standards for the military. And one of the things you want in the military is to have things so standardized that any properly trained soldier can replace any other soldier carrying on with the job. So you need a set of more rigorous standards for a situation like this. And that's part of why the STIGs are so specific. And it's also why we loosen the restrictions sometimes when we apply them to a commercial installation. The STIGs are works in progress. They're subject to updates. There's no guarantee of completeness. The people running them do a great job, but you'll see there's room for loosening and also for updating and taking everything with a grain of salt. Now, there are different STIGs for different platforms, including Windows and Unix and a lot of others, including STIGs for mainframes, and they have one for mainframes with RACF, one for mainframes with ACF2, and one for mainframes with top secret. The examples we're going to give you will work for all three of those. The STIGs don't address other aspects of compliance. They address security, the Security Technical Information Guide. They don't address data integrity or records retention or response time or identification of PII or lots of other aspects for compliance. We're just talking about security. And we're also talking or recognizing that the STIGs do not address regulations that are specific to your industry. The STIGs were developed for the military. If you're subject to banking regulations or insurance regulations or PII regulations, that will be a separate set of standards. So we'll keep that in mind as we walk through our examples. Because of all this, you just can't adopt the STIGs and blanket make them your standards. They do give you a great starting point. They give you a lot of things to think about as you develop your own standard, and you really need to develop your own. So to show you how you might develop your own standard, we're going to take 3 examples and show you how you might think about them and use them as you develop your own standards. We're going to use the current RAC-F STIG, but everything we're going to say will translate very easily into ACF2 and Top Secret. So we'll just jump in. Our 3 examples are going to be password content and length, TN3270 encryption, and tape dataset protection. Here we go. If you're using RAC-F and you want to see some of these settings, you'd look at the setter list report. The analog in ACF2, if you wanted to see these settings, you'd look at the show all report. In Top Secret, TSS modify status. Again, the last slide of this presentation has links for more information. And as we go through some of these examples, we'll occasionally mark things with a red asterisk. The red asterisk says there's more detail in the slide, the links that are referenced in the last slide, but we don't have time to get into them right here. So you can just follow up when we get to the last slide. So our first example, password content and length. The whole point of this is to make it more difficult for someone to guess someone else's password. And you know, if you had a password length of 1 and it was only alphabetic, half the people would make their password be the letter A. If you make the minimum password length 8 and you say you have to include letters and numbers, and maybe you say uppercase and lowercase, it's going to make it harder for someone to guess. This whole business can be complicated by some other things like calls for password phrases, which can have a length of up to 100 characters. The whole question of mixed case, upper and lower characters, and both of these would require you to identify every sign-on screen, every program with a sign-on screen, TSO, CICS, DB2, and maybe IMS, and OmegaMon, and maybe your tape management, and you probably got several dozen VTAM Apple IDs, that is programs with sign-on screens. And if you're going to support password phrases or mixed case, of course, you have to make sure that every sign-on screen has been modified to support mixed case or password phrases, and that you've tested them to make sure they work. For RAC-F, ACF2, and Top Secret, all 3 of these have ways that you can specify minimum password length and content and a lot of other things. So here's what the STIG says. We're going to use 2 parts of the STIG. One of them, the rule, if you have the STIG open in front of you, it's the rule RAC-F 0460. And it says to be compliant with the STIG standard, you have to have mixed case passwords supported. You have to support special characters. You have to have a minimum length of 8. And you have to say mixed case alphanumeric, which in RAC-F says you have to have at least 1 uppercase letter, at least 1 lowercase letter, at least 1 number, and 1 special character. And if you think that's overkill, well, maybe it is. You have to decide for yourself. Let's look at another requirement, a related requirement in the STIG. This one is labeled RAC-F 0462. It says you need a password exit. That is a program that you add to modify the logic of RAC-F. And usually you write these in assembler language or REX, and many shops don't like to have exits because they're maintenance nightmare sometimes. But this is what the STIG requirement says. You have to set the required content to include each of those 4 different types. You can't have the user's name or the user ID as part of the password. You can only have 3 unchanged positions from the current password. So, and the positions have to be consecutive. So if my password is table and I want to make it table 1, that wouldn't be allowed. But you can see the difficulty of programming that and making the exit work the way it's supposed to be set up. And you have to ask yourself, how much extra benefit do we get by making this requirement? The next one, no more than 0 pairs of repeating characters are allowed. And again, you'd have to ask yourself, do we get a lot of extra benefit from this? I don't know. A colleague of mine who speaks German tells me that there's one German word that has 3 of the same letter all in a row. I asked him, what word is that? He said, it's the word for apprentice bagpipe maker. I don't really know, but I'll take his word for this. Here's the next requirement. This is a list of prefixes that are not allowed to be used in passwords. And at one point, the STIG said you're not supposed to have any dictionary word at all, which of course would take a lot of work to demonstrate. So if you look at the ones listed here, and if you added your own stuff to this, don't you think your users would figure out which words don't work, and then they'd modify them to, change an O to be a 0 or make trivial changes to have the same effect? So again, not all of these give a lot of extra benefit. Some of these take a lot of extra work to implement. So if you're looking at the balance between what it costs for us to implement these requirements and the benefit we get, that is, how much does this reduce the likelihood that someone could guess someone else's password? And of course, with all of this, you have to remember, we hope we're saying 3 invalid passwords in a row, and we suspend or revoke the user ID. And you have to change your password every so often. And we train our users to make passwords easy to remember but difficult to guess. So with all of this, you have to ask yourself, how much benefit are we getting here? Most installations don't like to have exit programs. They're a headache to maintain. Mixed case passwords, and if you were going to use password phrases, would require modification and testing of all your sign-on screens. And as we saw on the previous slide, some of these standards are more restricted than we really need to reduce the risk to an acceptable level. Some of them, like the reserved word list, in my opinion, add very little actual value. So there are lots of different ways that you can reduce this risk to an acceptable level. The exact things that are listed here aren't exactly necessary. You can make lots of changes in these. And of course, using multi-factor authentication would reduce the risk a whole lot further. So our conclusion for the first example, addressing password content and length, the STIGs remind you of things you need to address. They give you a good starting point. But the guidance, the G in STIG is guidance, should be evaluated in what it costs and how much benefit, how much does it reduce the risk? And there's our first example. Here's our second example, TN3270 Encryption. TN3270, of course, is a program that lets you sign on over TCP/IP or over the internet. It lets you pretend that your Windows, your desktop PC, is an old 3270 style terminal, the old green screens. Now, we often use this to sign on to CICS and TSO and similar Apple IDs. And if for no other reason, if you're sending your user ID and password, you'd want to have encryption over the connection between sniffer programs and the way people can see stuff that travels over the internet. If your user ID and password are flowing over, you at least want the password encrypted. So here's what the STIG says. Again, if you have the RACF STIG in front of you, the rule version or number is ITNT00. I guess that's 0050. It says the telnet settings have to meet these requirements, and they say there are 3 specific cipher specifications. I'm not going to read them to you, but these things change all the time. At one time, DES was considered the best way to encrypt. It's now considered to be deprecated, and AES is considered better. The 128 and the 256 are the number of bits in the encryption key. There is an option that you can set in your configuration file for Policy Agent that says always have TCP/IP encryption set to meet the standard of FIPS 140-2. And that's Federal Information Standard 140-2, which is modified as needed to specify minimum acceptable encryption. So if you set that switch in your telnet, in your Policy Agent configuration file, then when they update the standards, IBM will update the way that is reflected in Policy Agent, and you might find that things don't work unless you stay on top of what's there in FIPS 140-2. If you don't set the switch or you don't rely on FIPS 140-2, you still have to pay attention because people will change the cipher specifications, the encryption keys that are allowed, and you'll need to stay on top of that to keep things working and make sure that production doesn't shut down or people can't do business with your mainframe computer because the rules have changed and you haven't stayed on top of them. So because of these changes all the time in the technology and the regulations, you can expect the requirements to change. And if you're doing 150-2, that may have more rigorous requirements than you really need. So our conclusion for our second example, some STIG requirements are going to force you to check all the time that you're keeping up with the changes. And you want to have encryption where you need it, but you don't want to set a requirement that says we're going to start failing things if we don't meet this unless we stay on top of it. So in some ways, you want a way to be aware if you're not meeting some of the standards that you decide to put in your policy without preventing production from running or preventing customers from doing business with your operation. Here's our third example. It's tape dataset protection. It's an option in RACF called Tape DSN, which says I want to protect tape datasets the same way that I protect disk datasets. It includes virtual tapes, and ACF2 and Top Secret also call it Tape DSN, or sometimes you'll see something like Tape Dataset Protection is activated. Now, Tape DSN is a very nice idea. You want to protect tapes, but since this was first developed, 2 other approaches have been developed that, in many people's opinion, are better approaches to provide tape protection. There are options in your tape management software where you can say, call RACF or ACF2 or Top Secret the same way we would if the option Tape DSN were set in the security software settings. But if there's no matching rule, or if the tape is a foreign tape, it's one that didn't come from our data center, allow the access, because tapes coming from other data centers might not have names that meet our dataset naming conventions. The second other enhancement is a member of the MVS Parm Labs named DevSup. I think that's Device Supervision, something, something. There's more information on this in the links in the slide at the end of this presentation. But this, again, gives you an enhanced way of addressing tape security without using the tape DSN setting in RACF, ACF2, or Top Secret. Now, the STIG says, and here's the rule number for the RACF STIG, it's RACF 0550. It says tape DSN should be active if you have a tape management product. And if you're using CA1, which is one of the major tape management software products, they say it should be active and the open, close, end of volume option should be set to off. And if you don't have tape DSN turned on, this is a finding. That means you didn't meet their standard. Well, These STIGs, the standards that we just looked at, they don't take advantage of the DevSup member and the tape management software. They don't address tape management software other than CA1. And they also don't address, there's some other security exposures that we're not going to have time to get into, but there's details in the links at the end. The 17-character DS name problem, the 2 files on a tape problem, and residual data on tape. So we'll draw this conclusion from our third example. The STIGs don't address all situations nor all known security exposures, and they don't take advantage of all the available tools for reducing risk. It would be almost impossible for the STIGs to keep up to date on every single little thing. So we need to recognize they're a good starting point. They give us stuff to think about, but they aren't the end-all be-all. Now, we could have a whole lot more examples, but I think you see from these 3 how you can take advantage of the STIGs. They give you stuff to think about, to address or include in your own policy, but you want to address the cost and the benefit that you get from whatever you put in your policy. And you also want to make sure you address some of the issues, security exposures that go beyond what's mentioned in the STIG. And you want to take advantage of tools to mitigate risk that maybe aren't currently included in the STIGs themselves. To wrap this up with our call to action, it's pretty much what I've been saying all along. We've got guides here. They're not comprehensive. They don't apply to every installation. They're a great starting point. They show us things to address, and a lot of them are things, I know this has happened with me. I've read the STIGs and said, oh, I don't agree with that. But you know, if I hadn't read the STIG, I wouldn't have even thought about that issue. I'm glad I read it here, but here's what I'm going to do in this shop. We've got many other sources to address in developing our own standards for compliance. Our legal and compliance departments can help us understand regulations that are specific to our industry. There's another government publication, 853, and there's a link to that in the last slide, that will also give you some additional things to think about. But the chief point is, if you don't formalize your own standard, other people are going to evaluate you using their own standard, and the STIGs are a good starting point for you to develop your standard. You need your own tailored standards for yourself, both to be able to demonstrate compliance, and also if you want to manage your installation's information security, you need a standard and a way to compare against it. Here's some additional thoughts or additional things that you can, information sources, including how to get the STIGs, how to get 853, and some more information on passwords and tape security, and a few other information sources. So with all that, I'll turn things back to Lisa, and thanks everyone for listening.
Thank you, Stu. Now here's Gary Bortner with an IronSphere demo.
Thanks, Lisa. Hi, as Lisa said, my name is Gary Bortner, and I do quality assurance at SDS. That's my job now, but I've been around the industry for a while, and I've worked in support as an SE, and a long time ago, even had a real job as a system programmer. In the next few minutes, I'm going to demonstrate IronSphere, but just as important as what I'm going to do is what I'm not going to do. I am not going to show you any slides. I'm not going to tell you why you need to worry about compliance or what compliance is. I'm not going to tell you why security is important. I'm not going to try to scare you with stories of breaches and fines for non-compliance, nor am I going to describe what STIGs are or why you should care. Stu has done all that. I am going to show you some IronSphere automated checks. First, I'm going to show those in Health Checker. Then I'll run some of the checks. Then I'll show the output in my browser. Well, in the browser, I will expand the results to show the details of what is being checked, anything that was flagged as a result of the check, and what to do about it. So first, let's go to SDSF. First, we enter CK in order to get into Health Checker. Then we need to locate the IronSphere STIG checks. They all begin with MVR underscore. So what I'll do is find for MVR underscore and locate the checks. I'm running the POC or Proof of Concept implementation, which consists of 21 checks. I've added another 3 checks that match some of the ones that Stu was talking about earlier for a total of 24. I pulled these additional checks from the almost 400 available in the full product, a number that has continued to grow, by the way. The way these STIGs are organized for z/OS is that they are grouped under Top Secret, ACF2, or RACF. We're a RACF shop, so that's what we're looking at. So here you can see the checks, the state, active or inactive, enabled or disabled, and then the status, successful, unsuccessful, inactive, exception, error, etc. If you're having a problem running some check, you can always turn debugging mode on. These checks are kicked off automatically on a schedule that you can determine. If I do a locate for next schedule, we'll see when the next scheduled date and time is. Now in this case, we're going to kick off a few manually, so I'm going to scroll back over to the left, and we'll go down and find the three of the STIGs that Stu was talking about earlier, specifically MVR ACF 460, which corresponds to RACF 0460, password mixed case special characters and length, MVR 462, which corresponds to RACF 0462, password exit, and finally MVR ACF underscore 550, which, as you may have guessed, corresponds with RACF 0550, tape dataset protection. When I enter an R in front of these in order to run them, you're going to notice that the status changes from successful to scheduled, starting, and then eventually to running. Now I'm going to jump over to my browser where I'm logged into the IronSphere server's UI. In the initial view, you see a percentage of risk. Basically, the way this is calculated is we take 1, 2, or 3 for each of the checks, and that corresponds to low, medium, or high risk. We add those all up and then divide by the max possible. Only failures are counted. On this first screen, we're reporting across all LPARs. When I drill into that, we see each of the individual LPARs. Now here we're only running on one LPAR, so we only have one choice. And of course, the percentage risk is going to remain the same. Now I'm going to drill into this LPAR, and we're going to see the results of the check. These can be sorted a number of ways. Initially, they're sorted by severity. Since I'm looking for some specific checks, I'm going to sort them by name. So I do that, and then we come down here, and we can see the 3 checks that we talked about earlier, 460, 462, and 550. Over here, we can see the timestamps, and if you look, you can see these are run a little more recently, so that's a result of me just kicking these off. Now I'm going to drill into one of these a little bit more. Let's open up 460, and here you can see information describing the check, the results, and we have a few findings here, and then what the fix is. The fix is essentially to do a set R password, mixed case, special characters, or for length, and for length, sorry. The information comes directly from the STIG. Here in the STIG viewer, we can see the same description that we saw earlier, and if I scroll down, we can see the same fix. Obviously, you're not going to see any results. In order to do that, you have to run the check. Moving on, looking at 462, which is the check for exit, you notice the severity is none. If I expand that, we're going to see information and fix, but no results. The reason there's no results is because there were no negative findings. We passed on this one. Finally, let's take a look at 550. This is the one for tape DSN. If we expand this, we're going to see that the result is tape DSN is inactive. Well, let's say that I really don't care about this. I don't want to protect tape dataset names. And so what I want to do is disable the check so that I don't have one coming up here and saying that it has a result when it's something I don't care about. So to do this, we're going to go back over to ISPF. First off, we'll check Health Checker, and you'll notice that the checks all ran successfully. Not a big surprise because we already looked at the results in the browser. Then I will switch screens and go into the PARM member containing the member that describes the various checks. I'll do a find for the tape DSN check, and notice that the status is checked to active. To inactivate this, it's just simple as changing that to inactive, saving the member, and then I'm going to have to do a refresh. To do a refresh, I go back into SDSF, do a command. The command is refresh of my checks. So that's a basic demonstration there. Now you may be wondering, why is the QA demoing the product? Well, he's demoing the product because he thinks it's really cool. The first time I ran the checks, After installation, part of my QA process, my reaction was, whoa, where have you been all my life? Now, that's not normally a reaction one gets from software, but there it was, a list of uh-ohs. The checks ran automatically. They explained the problem and what to do about it. Some of them were cleanup things, many were security, but it was all laid out for me. The hard work with coming up with the checks and running the checks was done for me. Instead of wondering what we should be checking for, wondering how to do those checks, and then writing, debugging, and running them manually, it just happens. Of course, there is some tailoring. As Stu said, these can be thought of as guides. You may not want to run them all. In our case, we turned off tape DSN, for instance. Alternatively, after looking at this and running for a while, you may find that you want to check for something that's not in the list. In that case, IronSphere provides a framework in which you can write and run your own checks. This concludes my demonstration. Back to you, Lisa.
All right, thanks a lot, Gary. Let's go ahead and address some of your questions. The first question we have is, are there any situations where you'd want to comply with every STIG without modification? Stu, would you like to take that one?
Sure, Lisa. I can't imagine anyone other than maybe the military, and even the military, wanting to comply to them all automatically. They're too comprehensive. They miss some things, and they are more rigorous than most of us need. In a lot of cases, they're designed for, plug any soldier in here and make it work. And so they don't include the balancing of the cost to implement the check and the benefit that you might get reducing the risk. So I can't imagine anyone being stuck with just doing them hard with no changes.
All right, thank you, Stu. Next question we have. We're thinking about using STIGs, not sure if it's a fit yet. We'd need a lot of custom checks. How would you do that in IronSphere? Gary, did you want to take that one?
Sure. To develop your own checks, the first thing you would need to do is create a key. As an example, one of the checks that we looked at had a key of MVR underscore ACF underscore 460. You create a key of that sort of format. For a homegrown check, you might do something like MVR underscore HGC underscore and then some number. The HG group has already been defined. If you want to make a new STIG group, there'll be an extra step involved. But after you pick out a key for it, then what you're going to do is code the check in Rex, compile it, copy to IronSphere's Rex lib. Then you add the check to the appropriate ParmLib member in IronSphere ParmLib member. If you remember when we set tape DSN to inactive, it would be that member there. Then we're going to create a text file describing the check and send that text file over to the server. The last thing you do then is add the check into Help Checker with Add New.
All right, thanks, Gary. Stu, I think this one's going to be for you. How often do STIG updates get released?
I see them coming out, maybe every other year, or sometimes even as often as twice a year. They update them all the time, but they come out with new fixed releases as they see enough change to make it worthwhile. So the website we gave you the link to points you to all of the current versions and also back versions. So you can get a good idea there, and that's also a good source for staying current and finding out what is the most recent release.
Okay, perfect. I think we have time for one more. Gary, I think this one's for you. How are the new checks added to the product?
Well, it's similar to what we do for when you develop your own checks, except for in this case, the Brex and everything is already coded. So what will happen is we'll get an update to the IronSphere's library of Rex execs. We'll add a new entry to the PARM member we discussed, and then the server needs to know about the check. There's actually a batch job that's provided to assist with doing all that for you.
Okay, awesome. Thank you. I think we're at the end of our webinar. We'd love to thank everyone for attending, and if you could complete the exit survey, we'd appreciate it. Thanks, everyone, and have a great day.